Hello friends, today I am going to talk about phase equilibrium. Phase equilibrium is very important in chemical reactions, in chemical engineering, because whenever the chemical reactions takes place, every time the reactants are trying to reach to the equilibrium state. Process कहाँ पहुँचने की कोशिश करता है? Equilibrium state में पहुँचने की कोशिश करता है. So the criteria for the phase equilibrium, there are three criterias for the phase equilibrium. So now let's discuss these three criterias. Now let's consider any homogeneous system in a state of internal equilibrium. So internal equilibrium का मतलब है यहाँ पर कि the system should be in thermal and mechanical equilibrium. That means the temperature and pressure should be uniform or constant throughout the system. Now there are one more criteria which is thermodynamic equilibrium. So for the thermodynamic equilibrium means because if there is a system and surrounding, there is the possibility of mass transfer, right? When the system is interact with the surrounding, वहाँ पर क्या possibility होती है? Mass transfer भी होता है. हीट ट्रांसफर पॉसिबिलिटी होती है, राइट? हीट ट्रांसफर होता है, मास ट्रांसफर होता है एंड फोर्स ट्रांसफर होते हैं, राइट? So your system in if you want to be, your system should be in thermodynamical equilibrium, then temperature, pressure and the another criteria which is there is no mass transfer को fulfill करना चाहिए. That means all three conditions should be fulfilled by your system. That means there is no mass transfer, no mass interaction between the system surrounding, and temperature and pressure is also uniform throughout the system. So to establish the thermodynamic state or thermodynamic equilibrium state, the third criteria should be, it is very important and that is necessary to fulfill the third criteria. Now, a system can interact with surrounding reversibly and irreversibly. In the case of irreversible process, a state of equilibrium is maintained throughout the process, and the driving forces are only infinitesimal in magnitude. That means the driving forces for the reversible process is very small. जो उनका मैग्नीट्यूड होता है वो बहुत कम होता है, एंड ड्यू टू दीज फोर्सेस जो भी चेंजेस होंगे सिस्टम में वो भी क्या होंगे? इन्फिनाइटिसिमली they are also very small in magnitude, so the changes are also infinitesimal. In contrast, in irreversible process, the driving forces are finite in magnitude, and it cannot be reversed by infinitesimal changes in the external conditions. So however, all irreversible process tends towards a state of equilibrium. So we have one equation which is known as Clausius inequality equation. Inequality equation, and with this equation is ds is greater than equal to dq by t. So the first we have the equality sign. Equality sign refers to a reversible process which can be treated as a succession of equilibrium state, and the inequality sign refers to the entropy change in entropy for a spontaneous process whose ultimate result would be an equilibrium state, or you can say it is irreversible process, right? So now from first law of thermodynamics, we know that dq is equals to du plus dw. So let's take, this is the equation number 1 and this is the equation number 2. So from equation number 1 we can replace this dq by TDS, you can write this TDS greater than equal to dq. So here we can replace this dq by TDS. So just replace it. So TDS is greater than equal to du plus dw, or rearrange this, du is less than equal to TDS minus dw, and this dw you can replace by PdV. So du is less than equal to TDS minus PdV. So this, you can see, this equation is the combination of first and second law of thermodynamic applied to a, this is the third equation. So you can see this equation is the combination of first and second law of thermodynamic applied to a closed system which interacts with its surrounding through a heat transfer and work of volume displacement. Now here you can see this equation is valid for cases where external pressure, you can see here, the external pressure is the only force. Pressure is the only force. और कैसा वर्क मिल रहा है हमको? एक्सपांशन वर्क मिल रहा है, ओनली फोर्स. एंड वर्क कैसे मिल रहा है? बिकॉज क्या हो रहा है? वॉल्यूम चेंज हो रहा है. जब वॉल्यूम चेंज होता है तो कैसा वर्क मिलता है? वी आर गेटिंग द एक्सपांशन वर्क. Okay. So this is the general equation which we get from the which we consider as a general equation for the phase equilibrium. Now here we have three cases. Now let's discuss. The first case is at constant internal energy and volume, right? So here we consider internal energy and volume आपका constant है, so you need to be consider an isolated system because isolated system does not exchange mass, heat or work with the surrounding. So this equation, we have equation D, third equation du dq. First from the first law of thermodynamics we have dq is equals to du plus dw. So if internal energy and volume is constant, that means your system is isolated system, then dq is equal to 0 and there is no work, so dw is also equal to 0. So once dq and dw is equals to 0, hence du also equal to 0. A well-insulated vessel of constant volume would closely approximate this behavior. This equation number, we have equation number 3, du less than equal to TDS minus PdV, right? This is our equation number third. So here, in this case, du is equals to 0 and dV is also equals to 0 because we have closed system. So volume will also not going to be changed. So if du and dV is equals to 0, then we have TDS is greater than equal to 0 and ds at constant internal energy and volume is greater than equal to 0. So in this equation, this is the first criteria for phase equilibrium. Let's take, this is the equation number 4. So the entropy is constant in a reversible process and increase in a spontaneous process occurring in a system at constant internal energy and volume. Right? So here we have two sign, inequality sign and equality sign. So equality sign refers for the reversible process and inequality sign refers for the spontaneous process. So आपको क्या दिख रहा है? एंट्रोपी क्या हो रही है? हमेशा rise हो रही है, increase हो रही है, right? So since an irreversible process leads the system to an equilibrium state, the entropy is maximum at equilibrium. No further spontaneous processes are possible, right? So at equilibrium, entropy is maximum, and when no further spontaneous processes are possible. Now let's discuss the second case. At constant temperature and volume. So we know that from Helmholtz free energy, we know that A is equals to U minus Ts. So just rearrange this. So U is equals to A plus Ts. Differentiate this equation. So we will get du is equals to dA plus Tds plus sdt. And from equation number third, we know that du is less than equal to Tds minus Pdv. So we can substitute here over here this. So in place of du, you can substitute Tds minus Pdv, right? Greater than equal to dA plus Tds plus sdt. So TDS cancel हो जाएगा, and then we have dA is less than equal to minus PdV minus SDT. And condition क्या है हमारे इस केस की? At constant temperature and volume. So change in volume and change in temperature will be equal to 0, right? So dA, change in Helmholtz free energy at constant temperature and volume, less than equal to 0. And this is the second criteria for phase equilibrium. So here in this equation, let's take this is the equation number 5. So equation 5 means that the spontaneous process occurring at constant temperature and volume is accompanied by decrease in the work function, right? Helmholtz free energy हमें क्या बताता है? It tell us about the work function कि आपका जो work है, how much work you are getting from the useful work we are getting from the system, right? So dA spontaneous process होगा तो less inequality sign होगा. We know that equality sign refers for the reversible process, right? Inequality sign at constant temperature volume, it refers for the spontaneous process. So spontaneous कब होगा आपका system? When work function जो होगा वो negative होगा, right? So this equation, this relation means the spontaneous process occurring at constant temperature and volume and accompanied by a decrease in the work function, and consequently in a state of thermodynamic equilibrium. Under these conditions, the Helmholtz free energy or the work function is minimum at these conditions at constant temperature and volume. So this is the second criteria for the phase equilibrium. Now let's discuss the last criteria for the phase equilibrium, which is at constant temperature and pressure. So we know that the Gibbs free energy is the function of temperature and pressure. So we have Gibbs free energy. So G is equals to H minus Ts, and enthalpy we know that H is equals to U plus PV. So you can just substitute here. So G is equals to U plus PV minus Ts. Now just differentiate this equation, above equation. So dG is equals to du plus PdV plus VdP minus TdS minus SDT, right? So from equation number third, we know that du is less than equal to TdS minus PdV. So just rearrange this. So du is equals to dg minus PdV minus VdP plus TdS plus SDT. So in place of du, we can substitute TdS minus PdV, dg minus PdV minus VdP plus TdS plus SDT. So माइन PdV cancel हो गया, TdS TdS cancel हो गया, and then we have dg is less than equal to, यहाँ पे क्या बचा, SDT ना, so we have VDP माइनस का प्लस हो गया वहां जाके माइनस SDT. So हमारा कंडीशन क्या है, एट कांस्टेंट टेम्परेचर एंड प्रेशर. सो चेंज इन टेम्परेचर एंड प्रेशर क्या है, टेम्परेचर एंड प्रेशर इज कांस्टेंट फॉर दिस केस. सो चेंज इन प्रेशर and change in temperature will be equal to 0. So dg at constant temperature and pressure less than equal to 0. And this is the very important phase equilibria criteria. And this equation, let's take, this is the equation number 6th equation. This equation means that the free energy either decrease or remains unaltered depending upon whether the process is spontaneous or reversible, right? If your process is reversible, then dg is unaltered, it is equal to 0, and if it is spontaneous, then it will be equal less than 0. That means spontaneous, if your process is spontaneous, then the change in Gibbs free energy will be equal to will be negative, and अगर positive होगी तो फिर आपका process क्या होगा, non spontaneous होगा. अगर dg is greater than 0, then your process is non spontaneous process. Since most chemical reaction and many physical changes are carried out under conditions of temperature, constant temperature and pressure, so this equation is commonly used criteria of thermodynamic equilibrium. It also provides a very convenient and simple test for the feasibility of a process. And no process is possible which results in an increase in the Gibbs free energy of the system. अगर Gibbs free energy इंक्रीज हो रही है, पॉजिटिव है, देन वो प्रोसेस पॉसिबल ही नहीं है, फिजिबल ही नहीं है. सो फॉर द फिजिबिलिटी, गिव्स फ्री एनर्जी, कोई भी प्रोसेस के फिजिबल होने के लिए आपका प्रोसेस गिव्स फ्री एनर्जी कैसी होना चाहिए, निगेटिव होना चाहिए, डिक्रीज होना चाहिए. सो these are the three conditions for phase equilibria. What we have discussed today, we have discussed the three phase equilibrium criteria. The first one is change in entropy is always greater than equal to 0 at constant internal energy and volume. This is the first criteria. That means for the spontaneous process, entropy, change in entropy at constant internal energy and volume will always rise. एंट्रोपी क्या होती है, हमेशा इंक्रीज होती है. सेकेंड क्राइटेरिया इज द हेल्महोल्ट्ज फ्री एनर्जी इज लेस देन इक्वल टू 0 एट constant temperature and volume. So the work function for spontaneous process, the work function or Helmholtz free energy is always decreasing. And the last is the change in Gibbs free energy is also less than equal to 0 at constant temperature and pressure. And this is the most important phase equilibrium criteria. This criteria is commonly used in chemical industries, in which Gibbs free energy is always less than equal to 0. For the reversible process, it is equal to 0, and for the spontaneous or irreversible process, it should be less than 0. And it is also help us to, this criteria is also help us to check the feasibility of any process. So this is all about the phase equilibria. Thank you.